Somehow they got into our account.
Probably Miss Davis from the dead.
Steven's like, I'm going to just make sure I give it to everybody right now. Metro. Anyway. All right. So good news. See, there was other stuff I knew I had to tell you. All right. We are going to write down, this is going to be annoying. There are 8 limit laws. Okay. We're going to do limits algebraically, and you have to know all these lovely limit laws. And they're annoying, but it's really about notation. And then I will show you how to do it much, much more easier. All right, so your first limit law is the limit of a constant. Meaning, the limit as x approaches a of some constant k. Okay, so if I said, well, actually, let me tell you what it equals. It equals k. If I said the limit as x approaches 2 of 3, guess what the answer is? If you approach, as you approach 2 and the 3 is your value, guess what, from the right and from the left, it's going to be 3. It's going to be this straight line. So the limit of a constant is the constant. The limit of the constant, it's the constant. Limit of the identity function, which looks like this, the limit as x approaches a of x. X is always your identity function. And that answer is A. So let me give you an example of that one. The limit as x approaches, I don't know, 5 of x, okay? So again, the identity function, remember, is that line that goes right through the graph. So as you approach 5, it's going to be 5 on that line. What if this was a 6? It's going to be 6. What if this was a 2? It's going to be 2. So the limit of an identity function.
What if it was 3?
It'd be 3. What if it was infinity? Infinity. So very cool. Now, I'm not going to show you examples for the next because we're going to work through them. They're all going to make sense to you. And again, if they don't, it will when we do the examples. This is the sum and difference limit laws. Sum and difference limit law. And it says the limit as x approaches some number a of f of x plus or minus g of x. Okay, so meaning if you're adding 2 functions together and you're taking the limit of all of it, you can actually separate that into each limit. I don't want to use the word distribute. It's not the right word, but that's really kind of what you're doing. You'll see what I mean. Meaning you take the limit as x approaches a of f of x, and you add that or subtract that to the limit as x approaches a, sorry for the squeeziness, of g of x. Okay? So I remember I had a professor and he used to say, the limit of the sum is the sum of the limits. And he'd say that all, the difference of the limits is the limits of the difference or whatever. And I'm like, okay. And I never understood that what that meant, but really all it is think of this right here. And again, this is wrong mathematical terminology, but this is how I remember it. It's just kind of like distributing it. So you can take the limit as x approaches a of f of x, and then the limit as x approaches a of g of x. That's all. All right, then limit law number 4. There's 8 of them, so I'm trying to get through. This is the scalar multiplication limit, or scalar multiplication law. And it says if you take the limit as x approaches a of some k times a function, some scalar, that's what we usually call k in mathematics. K is a scalar, a number, okay? Now, what you're allowed to do is you're allowed to take that k out and then just take and then multiply it by the limit of the function. Okay, so if this was a 2 and this was an x squared, you could take the 2 out and then just take the limit as x approaches a of x squared or whatever. And again, if this isn't making sense, don't worry. This is just all really you understanding, like, what does this crazy notation look like? So don't freak out about the notation. We're going to learn it. The product law says the limit as x approaches a of f of x times g of x. Take a guess what you would do there. Multiply the limits. Again, it's that idea of, distributing. Don't think of it like that, but I mean, it's really the best way to think. You take the limit of this guy, f of x, times the limit of the g of x. Hey, and guess what? There's a quotient one too, and I'm pretty sure you could probably figure that one out as well. The limit as x approaches a of f of x over g of x. And then what you do again is you distribute that limit. You put the limit on the top. So the limit as x approaches a of just the f of x over the limit as x approaches a of just the g of x. Okay, we're almost done. And then it'll make sense when I show you why we're doing this. 7 is called the power law, meaning if you had the limit as x approaches a of f of x to the n power, like that, what you can do again is you take the limit of the function and then you raise it to the power. So you would do something like this. You would say the limit as x approaches a of the function and then raise it to the power n. If you take like high level math classes, so you get, you take Calc 1, Calc 2, Calc 3, then you have what's called differential equations, which is really Calc 4, and then you have advanced calc, and then you have even more advanced calc. Once you get to those advanced levels, this is what you work with. You don't even work with numbers. It's all these right here. Do you remember doing proofs in geometry? That's what the higher level math is. It's all of these, and you put them in proofs, and it's horrible.
Why would someone do that?
Exactly, but people do. I was one of them. Actually, I only had to take a few of those classes because I was like, I'm going to the applied math, which is this is the theory math. I do the applied route. I want to apply it.
You should just say theory isn't technical.
Isn't technically real.
Why are we? You got to take it.
All right. Then the last one is the nth root law. So the limit as x approaches a of the nth root of f of x. And again, if you haven't noticed the pattern here that we're doing, we're always taking the limit of the function and then we're doing whatever that grouping is. So anybody have a guess of how you would rewrite this? Where would I put that limit? Underneath. So I'd say the nth root of the limit as x approaches a of f of x. Okay? Now, let's apply this and find out why this works. So if I had something like, you will have this on a quiz, by the way, so if you want to make sure you write it down. The limit as x goes to 2 of f of x is 3. The limit as x goes to 2 of g of x is -4. And the limit as x goes to 2 of h of x is 5. And I want you to do the following. Find the limit as x goes to 2 of 2 times fx plus g of x. And we'll do one more. Of h of x minus g of x over. They make these look so hard, and really this is probably one of the easier questions. So again, if you want to make your parents kind of freak out and show them how smart you are, give them this problem. It's really just about understanding notation and whatnot. So according to our limit laws, when you have the limit of all this right here, you can pretty much just take the limit of each one and then times it by 2, right? I'm not going to rewrite that right now, but what do you think you would just do? What would you plug in?
3.
Exactly. Because, and I mean, really, this is what you're doing. You're doing this. You're saying 2 times the limit as x goes to 2 of f of x plus the limit as x goes to 2 of g of x, which we already have up here, right? We have those limits. So this would just be 2 times the limit as x approaches 2 of f of x is 3, plus the limit as x approaches 2 of g of x is -4. And then just work it out like you just normally would. I mean, it's really one of the easiest questions, but it makes it look so hard. So this is what? -2? Done. All right, what about that one? The limit as x approaches 2 of h of x minus g of x over f of x. What do you think that would just be? So what would we get? 5 minus -4 over 3. So what is that, 3? Now, if this said as x goes to 3, would you be allowed to do what we just did? No. Okay? These all have to be the same. Okay? Very important. You can't just do it if it says 3 or if it goes to a different limit. Then you have problems there. So you kind of want to look at that. But so that'll be really, really easy for you tonight. All right, now let's apply those limit laws. This is the most important thing from today. Oy, these pens get so tight. So this is part 2, using limit laws. So you are no longer going to be able to, you can always fall back on a table, but I don't want you to anymore. I want you to be able to do all of your limits algebraically. Okay, I'm going to do this the way the book is going to require you, and I take it back, the way the worksheet, because I'm giving you a worksheet today. The worksheet is going to want you to do this for the first couple of them. Do not do it the way that I'm about to show you. I want to show you it because I want you to see these are how the limit laws are used, and then you're not going to do it like that ever again. Yay! Okay, but I just want to show you. So this right here, the limit of this whole function can be rewritten as so. You can actually go, hey, the limit as x goes 4 of x squared minus the limit as x goes to 4 of 6x plus the limit as x goes to 4 of 3. I just did the limit law with addition and subtraction. Agreed? This one right here, I can actually rewrite that as, again, the limit as x goes to 4 of x and then square it. That's what a limit law says I can do, right? Look at all our limit laws. It says you can just put the limit right there next to the function and then do the nth power. This one, I can actually take that scalar right there, that 6, and I can pull it outside. Minus 6, and then multiply it by the limit as x goes to 4 of x. And this one is the limit of a constant. And now again, this is very, why are we doing this? Why is it making it so difficult? I'll show you the easy way in a moment, but I want to show you this is where the limit laws are used. So then let's go back to really those first 2 laws, kind of show you right here. Let's just do this one right here. The limit as x goes to 4 of a constant. The limit as x goes to 2 of 3 is what? 3. What is the limit as x goes to 4 of 3? Also 3. This is the limit of the identity. The limit as x goes to 5 of x is 5. So the limit as x goes to 4 of x would be what? 4, and then you're going to multiply it by that scalar 6. This one is also the limit of an identity again, which would be 4, but then you're going to square it. Okay, so now stop right here and look at this. Couldn't I have just plugged in 4 right here and here? 4 squared minus 6 times 4 plus 3. Y'all, that's the first law that you're going to do on every single limit problem tonight. It's called direct substitution. When you get limits and you do them, the first thing to do is just plug it in, plug it in. Good old directly substitute. Don't do this. Don't do what I just showed you. It's good. I mean, again, it goes back to the theory of math, but really this is all you had to do and you get, what is it, -5? I think it's -5, right? Yeah. That's all you have to do. So every problem tonight for homework, the first thing you do, plug it in, direct substitution it's called. Let's do another one. Limit as x goes to -2 of 4x cubed plus 1 over x plus 5. And we'll do another one. Limit as x goes to 3. Now, again, they're going to say, use the limit laws to find the limit. Don't. Plug it in, y'all. Take Mr. -2 and plug it in everywhere you see an x. So 4 times -2 cubed plus 1. So that's 8 times 4 is 32. 32 plus 1 is 33. No, I'm bad. My bad. That's -8. -32. -31. My bad. And then -2 plus 5 is 3. Done. -31/3. That's it. I mean, you can check the table if you want to. You can check. It's going to go to -31/3. Let's plug 3 right here. Square root of 8 minus 3. Square root 5. Done. Done. So the first job tonight, this is your first thing to do, direct substitution. Plug it in, plug it in. Can you handle that? All right. But of course, they're going to give you different ones. They're not always going to be that easy because, hello, we're in calculus. All right. So what happens when I give you something like this one? This was number 4. The limit as x goes to -4 of x squared minus x minus 20 over x plus 4. So let's see what happens here. Just real quick. Again, you always do direct substitution. So if I plug in -4, I would get 16 minus -4, by David, minus 20 over -4 plus 0. I don't even care what the top is because what does the bottom become right now? Are we ever allowed to have 0 on the bottom? No. And so if you get 0 on the bottom, do not assume it's a D&E. Do not say, oh, D&E. That's not right. Okay? And I get that every year. People are like, oh, 0 on the bottom? D&E. No. Go to your table. You can check it there. But there's another way to do this one. When you see a trinomial, everybody, what in your nature do you want to do right now with it? That's exactly right, which sadly enough, the pre-calculers don't know how to do, which I'm really mad about. Because they didn't take Amy Davis serious during the COVID quarantine. They just didn't do the end half of her stuff, and I'm really mad about that. I have to zip this out, by the way, Sharon. Zip this. I'm yelling at myself. All right, anyway, what two numbers multiply -20 and add to -x? 5 and 4?
Yeah.
Negative, positive? Huh, what can you do with that? Cancel? X plus 4 and x plus 4? So this actually reduces to the limit as x approaches -4 of x minus 5. Can you plug a -4 in now? You sure can. -4 minus 5 is -9. You can check your calculator table right now. That's what it will go to. The limit goes to -9. What? So rule number 2, factor. If direct substitution doesn't work, then you've got to go back to factor. Check to see if factoring. Let me give you one more of those because I want to make sure you're all on the same page with that. The limit as x goes to 3 of x minus 3 over x cubed minus 3x squared minus 7x plus 21. I'm going to tell you right now, the bottom is going to go to 0, so you might as well factor the bottom right now. And that's what Miss Davis would call her Fantastic Four. Again, there's a whole group of children that don't even know what that means right now. Fantastic Four. -7, and I get a positive x and a -3, and then regroup that. X minus 3, x squared minus 7. So then what can cancel? Obviously your x minus 3. Please don't mess this up. They have students every year mess this up. What's on top right now? 1, not 0. 1 over x squared minus 7. Now take the limit of that as it approaches 3. So you would get 1 over 9 minus 7, which is 2, right? 1/2. That's it. So first rule on tonight's homework, everything you're going to do is try to do direct substitution. Second rule, everything you're going to do is factoring. There's 2 more different things I want to show you real quick. What happens when you have a square root? Okay, this one right here. So square roots are funny. Again, if you put 9 right here, wouldn't you get 0 in the bottom again? You'd actually get 0 over 0. Okay, again, that is what we call an indeterminate form in mathematics. So that means you have to do something else before you choose to say D and E. You can't just say, oh, D and E. No, you have to do something else, okay? So what you do is, and this is going to seem weird, but radicals require conjugates usually, okay? So if you see a radical, try to multiply by the conjugate. So even though the radical is on top, which it's allowed in mathematics, you still can multiply by the conjugate. Do you know what the conjugate of this top would be? Do you remember that fancy word? Conjugate means you just change the sign in the middle. So you're going to multiply the top by square root of x plus 3 and the bottom by square root of x plus 3. Because in mathematics, you can multiply the top and bottom of any fraction with anything you want. We're multiplying by a polynomial. It's totally allowable. Okay. And what happens is when you FOIL a conjugate, you remember you don't have to oi, you just have to fla. That's me trying to be Miss Davis and no one learned it. So you just do first times first. What's square root of x times square root of x make? Just x. What's a negative 3 times a positive 3 make? Negative 9. The middles will drop out, so that's why you only have to do the first and the last. The bottom, don't FOIL it. Leave it like this, x minus 9, square root of x plus 3, because look what happens. What's going to cancel from top to bottom right now? So now you have a 1 over the square root of x plus 3 on the bottom. And now let's try to take the limit as x approaches 9. Watch what happens. I get 1 over the square root of 9 plus 3, or 1 over 6. So if you see a radical tonight, you're going to need to multiply by a conjugate, more than likely, okay? Unless it's just direct substitution, that, you know, that will help you out. It might not. All right, and then, well, I know there's so many I just want to show you. They get so complicated. I'm just going to show you one of these. If they give you something like this, okay, where they have crazy looking fractions, and again, if you try to put 0 into the denominator there, it's going to get a 0 on the bottom. If you put 0 here, it's going to get a 0 on the bottom. Don't just be like, Danny. You have to say, oh, that's an indeterminate form. I got to do something else. My hint to you with multiple fractions would be make one fraction. Use your algebra skills to make this one fraction. So what would be the common denominator for this guy up here? Wouldn't it just be x minus 5, right?
Yes.
So then what do I need to multiply this top by? Just x minus 5. This guy I don't have to, I multiply by 1, right? It's already there. So this would be x minus 5 plus 5. So those will cancel. And you're left with x over x times x minus 5. Oh, what else is going to cancel? The x's. So you're left with 1 over x minus 5. Now try to take the limit of it as x goes to 0. So plug it in, plug it in. What do you get? Negative 1/5. That's actually the limit. Okay? Yes, sir.
Is the answer to a problem ever going to be D and E?
Yes. We found that, right? Those piecewise functions do D and E. And I'm actually going to give you one right now. See, you're like already ahead of me. There are times when 0 is the denominator, you would get a D and E. But like I said, I'm going to show you one right now. This is a lot. I know. I'm almost done. Honestly, I know you're doing so well. I only have 1, 2. I really have like 4 left. I can do it. We can do it. Okay, I know. It's long, but I'm not doing any more. Give me like literally, all right, 7 minutes and I will be done. I'm sorry. This is a long one. 28 minutes, but I was talking a lot. All right. Left hand, right hand, regular good old limit of f of x, and I'm going to write out a function right here. For x minus 3 when x is less than 2, and x minus 3 squared when x is greater than or equal to 2. Okay, let's talk about these because you do have one of these. These piecewise functions and finding limits from the left, finding limit from a right, and then finding limit left and right, which is this one right here. Okay. So if you're coming from the left, and again, always start with direct substitution. Which piece would you plug it in? To the top or into the bottom? If you're approaching 2 from the left, would you plug it into the top or into the bottom? And tell me why. Why top? Because it's less than 2. Okay, so plug 2 in right now. What would you get out? 4 times 2 minus 3 is what? 5. That is the limit from the left. From the right, you would plug it into the bottom, right? So this was in the top. This goes to the bottom. So I would get 2 minus 3 squared, which is what? 1. And this is an answer to Liam's question before. What if I had just written the limit as x approaches 2? What would you write here? Why D and E? Correct. D and E, because the left and right hand limits are not equal. Okay, so there's an example of where you do have a D and E and it does occur. Making sense? Kind of. You're like, sure, we'll keep going. I know, I'm sorry. There's just so many.
You should just do our homework problem.
No. 9. It's really not. Again, most of it is direct substitution and then factoring, so you should be fine. I know. I want to show you this one. This is kind of a neat, interesting one. Kind of goes back to the laws. And then I got to show you these because I'll take a break for a minute and then I'll show you these. How about that?
How about a 5-minute
We
break?
should just finish it.
It's up to you, y'all. But this is important stuff. So, if I do x, I factor it. Obviously, nothing can cancel, right? If I plug in 2, not going to work. And this is 2 from the left, by the way. Okay. So, what you could do is, and I know this is going to be brand new for many of you because I don't think you've seen this, and you've got to start learning this because it's going to help you on the next one. When you are multiplying by fraction, do you know that you can split up the fraction? So you could rewrite this as the limit as x approaches 2 from the left of x minus 3 over x, this guy, times the limit as x approaches 2 from the left of, what would I be left with on top? Well, a 1 over this one, x minus 2. Okay? And what that does for me then is if I plug in 2 right now, coming from the left, this limit would go to what, -1/2? Yes. If I plug in 2 here, I get a 0 on the bottom, do I not? Okay. But this should be a picture that you are familiar with. This is the parent function that looks like this. This is the hook that has an asymptote at 2, 1, 2, like this. And then the hook is here, and the hook is here. So you could graph it and check it. But as you approach 2 from the left, okay, so let me get out a different color here. From the left, here's the left. God bless you. I'm approaching 2, now I'm at 1. Here I'm approaching 2, where am I headed toward? So if I have a negative 1/2 times a negative infinity, what would be my limit? Take a guess. Not negative infinity, positive infinity. Now, that was a way of doing it. You could have just plugged this into your calculator and put parentheses around the top and the bottom, and then looked at 2 as it approached from the left, and you would have seen the numbers getting larger, like you did on the table worksheet. Okay, so that would have been fine. Let me take a break here. I'm gonna do these last few in a minute because I'm gonna let you start this lovely homework because you'll see it's not that bad as we're doing. And then I'll do the last few examples. Actually, I probably will do the homework problems with you that refer to this. I know, it's too nice of me.
You are benevolent.
I try. I can see you dying on me, and I don't want you to die because I love this stuff. This is really easy cake stuff. So I'm gonna keep the screen going. Poor Tommy, he's not here. He can hear me on the video. All right, so you're doing, let's circle them so we're all on the right part together. 1 through 7. And I left you 37, 39, 40, those ones, okay? And put in your notes the following infinity limits of polynomials. Infinity limits of polynomials, okay? Because again, suppose you do take the SPCC class and you're not allowed to have a calculator. What do you do with infinity then? Like, how do you algebraically manipulate infinity?
Plug in a million.
Yeah, I mean, you could, but there's mathematical ideas behind it. So I'll show you what I'm saying. So I'm going to take the limit as x approaches infinity of a really long looking thing. 10x plus 14 plus 6x squared minus 3x to the 4th. And then I'm going to do the same one, but this time I'm going to go to negative infinity for that same polynomial. Okay? So I want you to watch what happens. Just think about it logically with me. There's really no algebraic way of doing it. It's really more of a logical way. But as x gets more and more large, just start with like 10 times 10 plus 14, 10 squared times 6, minus 3 times 10 to the 4th. What's going to happen is all this stuff right here is going to really mean nothing because this is your highest degree, correct? With a negative coefficient. So let's just take 10 again. 10 to the 4th power is 10 with 4 zeros, right? Or a 1 with 4 zeros. Times a negative 3 makes it what? Negative 3,000, 30,000, right? All right, what if I put 1,000,000? Where would I be at now? Negative like 30, whatever. So where am I headed toward right now, logically? That's the limit. Well, what if I put in a negative large number? Again, all this junk really doesn't matter. You're just adding or subtracting to it. It's really the highest power here with the coefficient. So if I took a negative number and I raise it to a 4th, what happens to it? It becomes what? Positive. But then I multiply it by a negative 3. Now it goes back to being what? So guess where this goes to? Okay, so let's now look at one of your homework problems on this. Let's look at this first one. Number 35. As x goes to infinity of 5 minus 2x squared plus 7, don't even worry about, look at the highest power right now. 7x to the third. As x gets more and more larger, where are you headed for? Positive infinity, okay? Where's another one? Did I give you another one like that? Did I give you 38?
41.
40 I gave you? Okay, yeah, don't do a 48. Then don't do fractional ones yet. We're about to do that in a minute. Well, let's look at 38. Just let's do 38 anyway. Where do you think 38 is headed for? If you plug in large positive numbers. Why negative? Because it's a negative in front. Does that make sense? So polynomials are really cool because they either go to infinity or negative infinity if you're going to infinity. If you were going to 2, what would you do? Plug a 2 in. But if you're going to infinity, you plug a large number in it. Okay, so there's that. That I needed to show you. And that now I want to show you the fractional ones. But it's all based off of a definition right now that I want you, well, not a definition, but you're going to write it up. The limit as x goes to plus or minus infinity of 1 over x equals, write this down. This is what the next thing is written. So I want you to think logically with me. I'm going to show you what it equals. You're going to actually tell me what it equals, and then we're going to use this to do what the next part is about. As x gets more and more, we'll start with positive. As x gets more and more largely positive, so 1 over 100, 1 over 1,000, 1 over 1 million. Where am I headed toward? 1 over 100 is like 0.001. 1 over 1,000 is I'm headed to 0. What about with negative numbers? 1 over negative 100 is negative 0.0001. Negative 1 over negative 1 million is negative 0.00000. Where am I headed that way? Also 0. The limit as x goes to infinity, either positive or negative, of a fraction is 0. How is that going to help us? Well, and these are our last examples here. I made a key there. And I called it the infinity limits of fractional polynomials. So the limit as x goes to infinity of 3x cubed minus 10x plus 2 over 4x cubed plus 20x squared. Now, I want you to be really careful and notice something before you start doing this, because this is where everybody always makes mistake every single stinking year. They see a fraction and they go to try to like FOIL it, or they plug a number in or something like that. The trick I'm about to show you only works if you're headed toward infinity. Only works if you're headed toward infinity. Not if you're headed toward 0. If you're headed toward 0, plug a 0 in. If you're headed toward 2, plug a 2 in, okay? But if you're headed toward infinity, you're allowed to do the following. You take the highest degree that you see right now, which is an x to the third, right? And you divide everything by x to the third. Why am I allowed to do that? I'm allowed to do anything to a fraction. I can add 2 to the top as long as I do it to the bottom. I can multiply by a polynomial on top as long as I multiply on the bottom. So I'm going to divide everything by x to the third, the highest degree, minus 10x over x to the third plus 2, over x to the third, all over 4x to the third. Bear with me. You can write this down because this will be more sense in a minute. Okay, now, if it can reduce it. So for example, this one right here, x to the third and x to the third cancel, right? And what are you left with? Just 3, right? So you go like this in math. You go make an arrow and write 3, okay? This one reduces to what over what? 10 over x squared. Okay, now, according to this, if you have an x in the denominator at all and a constant on top, and you're going to infinity,
0.
it goes to 0. The limit will go to 0. So if you're left with an x on the bottom, it goes to 0. Are you left with an x on the bottom here? It goes to 0. Are you left with an x on the bottom on this one right here? What about this one? What does this reduce to? So the limit on top is 3. The limit on the bottom is 4. That's your limit. 3/4. Okay. Let me do another one real quick. Limit as x goes to, we'll do negative infinity because it doesn't matter as long as it's an infinity, of 6x to the fourth plus 2x minus 11 over negative x to the fifth plus 17x to the third. Okay, what's your highest degree? X to the fifth. So pretty much what you're doing is, I'm going to squeeze it in here. You're dividing this by x to the fifth, this guy 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 by x to the fifth. Okay? If you reduce it and you're left with an x in the bottom, it goes to 0. So if I reduce this, wouldn't I have 6 over x? So that goes to what? This whole thing goes to 0. What about this one? Still goes to 0. What about this one? 0. What about this one? What about this one?
0.
Okay. So on top I have 0. Is that allowed? Yes. 0 on top is allowed. If you ended up with a 0 on the bottom, you'd have to do something else, like look at a table. But on the bottom, what am I left with? So guess what's 0 divided by negative 1?
0.
That's the limit 0. So let's look now at whatever other two little problems I had here are, which other two did I give you here? 39? Yeah. 39. So what are you going to divide everything by? X to the 6. Divide everything right now by x to the 6 and tell me what your limit is. Anybody get it? One-third is right. Good job. All right.
First one I got right.
Yay. Okay. Now again, this trick only works for fractions, only for fractions that go to infinity or negative infinity. Not to 0, not to 2, only for fractions that go to infinity and negative infinity. I'm going to do 40 with you right now. You can do it on your piece of paper, but I'm putting it up here just so you can see. So you would start this off, because it's going to infinity, as dividing by what? What's our highest? X to the third? X to the third, x to the third, x to the third, x to the third, x to the third. So the top would go to 14, a 0, a 0, a 0, a 0. We have a problem, everybody. You cannot have 14 over 0 and say that that's your answer. And you cannot write D&E anymore unless you do a second check. Meaning, what other ways could you do it? The way you did it before, using a table. Okay, so I've already pre-programmed this in a calculator just to save time, because you've all been so patiently good and I missed you. But I put it in here already. Again, notice I put parentheses around the top, divide, parentheses on the bottom. And what I'm going to do is I'm going to go to my table. I'm going to start it at like 100. Again, I'm going to infinity. And I'm going to go up by 0.01 because I want to get more and more largely positive. So going to 100, I'm going to look to see what my answer is. I got 339.02. All right, now let's make it go to 1,000. Actually, let's go to 10,000. 34989. I mean, and you could just do one more just for the heck of it. Let's go 1,000,000. 1, 2, 3, 1, 2, 3. And I'm going to 3.5 E6, which means 3,500,000 when I'm at 1,000,000. So where am I headed, everybody? Infinity is a limit. You can have infinity is an actual limit. So don't just say, oh, D&E, okay? But there's an example of that one. So there was number 40. So really, you just only have about like 5 more problems to do for homework tonight, and we're done. Yay, see? It's bad, but it's
How
not
would you
bad.
do that though? If,
You didn't have a calculator?
Yeah.
They